Good, how are you? Sorry? Yeah. Yes. Okay, so let's make a start. Welcome to NVO3, which is in Montreal, not in London still, as it says on the slides that we uploaded. Is this mic not on? It's on, I've just got to be very, very close to it. Okay, thanks. My name is Matthew Bocci. Sam, my other co-chair, couldn't make it to this meeting, so I'm going to try and do this on my own, so please go easy on me. We also have a new secretary, Iju, who's going to help and take the minutes, so thank you very much. Here is the notes well. I will leave it up for a few seconds if you could look through it, please. Okay, blue sheets. So there are two sets of blue sheets going around, one on each side of the room. Please sign the blue sheets. Iju is going to be our note taker. Thank you. Okay, I already mentioned we have Iju taking over as working group secretary. Okay, agenda. We only have, including this status update, 5 items on the agenda today, so we have a reasonable amount of time. Any comments on the agenda? I should note that 2 of these presentations are going to be remote on Meet Echo. Silango and Greg. Right, milestones. So these are out of date again. So I've put up had a first pass at doing some revisions to the milestones. That includes, well, we have drafts for control plane requirements, old drafts for control plane requirements and the NVE to NVA, but we don't have a draft really for an NVE to NVA control plane solution. So I kind of, given the lack of progress on the control plane requirements and the lack of a current NVE to NVA control plane solution draft, I've actually taken that off proposed to take that off the milestones for now, and moved some of them back. But I did add some security milestones for the security solutions and the security requirements submission to the ISG. Hopefully it's at least realistic to get the security requirements published this year. Okay. I'll send these to the list, so if you could take a look at those and let me know if you have any comments, and then we'll get them updated on the charter. So, working group document status. So we have quite a few RFCs, and we have one new RFC since the last IETF, RFC 8394, which was the split NVE control plane requirements. So, a few notes on some of our working group documents. For the data plane encapsulation, we have a new version of draft Genève. This is on the agenda. There's been some discussion. Most of the discussion on this recently has been around the security section, and that's going to be discussed during the session today. We would like to really push this for working group last call after this IETF, ideally. There is also draft IETF NVO3 which is kind of the outcome, documents the outcome of the encapsulation design team. And as we said before, we would suggest putting that forward for working group last call once Genève has been through the working group last call process. We have a couple of ongoing working group adoption polls. So after the London IETF, we started a poll on the Genève security requirements. And there was quite a lot of discussion around that, and that's on the agenda today. But as it stood, we think that there wasn't sufficient consensus on the content of the document to adopt it. So hopefully with the latest revisions that Daniel's going to talk about, we will be able to run another adoption poll for that. We also have a draft on EVPN applicability to NVO3. That's currently under a working group adoption poll. Please read the draft and comment it on the list, or state if you support or do not support adoption of that draft. Okay, the Virtual Machine Mobility Protocol, the VMM draft. So this has been around in the working group for a long time. We started a working group last call, but we didn't close it yet due to really a lack of responses on the mailing list. The chairs requested both reviews from both the ops area and the routing directorate, and we got reviews back from both of those. The ops area review in particular has quite a few comments, including a review by the TCP maintenance working group. So I'm just wondering if one of the authors could maybe come to the mic and let us know what they plan to do about these comments.
Yes, sir. Hello. Yeah, Bashir Sarikaya. I'm one of the authors. The ops area review has a number of comments, as you mentioned, and we believe that we can revise based on those comments easily in a few days. After, I mean, next week, early next week or something. And that's I don't know about TCPM. How can
yeah, I mean, I think I'll talk to the chairs of that working group, see if we can get some review from
contact them and get them a review. So if we get the other reviews, we'll be happy to look at them and do required revisions.
Okay.
Okay.
Okay. I just wanted to get like a sense of the room about who's read this draft, because we didn't get any responses on the mailing list from the working group in general to this working group last call so far. So could you please raise your hand if you've read this version of the VMM draft? That might explain it. So it would be much appreciated if you could take a look at this draft and comment on the list, because we'll probably try and do another working group last call after the ops area review comments have been addressed, and probably after we've done some, done a review of TCPM. Okay, so just one one other item. So there's been a proposal for a potential joint IETF and IEEE 802 workshop on data center technologies in Bangkok, which is the next IETF, which happens to coincide with an IEEE meeting. Paul, would you like to say something?
Yeah, this is Paul Congdon. Yeah, the IEEE plenary meeting is immediately following the IETF meeting in Bangkok at the same hotel. And so we wanted to try to take advantage of that opportunity to see if we could get together some of the thought leaders around data center technologies. The IEEE just recently approved a project around congestion management, and it's intended to work work with higher layer congestion management in the IETF as well. So we think that there would be some fruitful discussions in that area. There's also some strong interest in the IEEE, where, of course, all the switch vendors are and ASIC vendors around how we interconnect other data center technologies, such as the overlay networks as well. So the interplay between layer 2 and layer 3 would be a great opportunity to have such discussions. Again, congestion being one of the interesting areas. A lot of the new proposals here in the IETF are using option fields in the TCP header, which would be inside the encapsulation. So it's not clear how the fabric switches themselves would be able to see or do anything about that. So it would be interesting to know how we can communicate indications of congestion and things like this to the edges of the network as well in order to take appropriate action. So the proposal is that this would take place on a Saturday immediately after the IETF. The IEEE has indicated they have room space available, so there would be no additional meeting fees or anything like that. But the agenda is not fully set yet, so we're looking for trying to hone in on the agenda, and it would probably be announced by the IAB or something in the IETF. Any questions about that? Or
okay, so I'll also post something to the list, the NVO3 list about this. I guess are you looking for feedback on potential topics that people would be interested in? Yeah,
correct. We're looking for feedback on topics. As I mentioned, the current thoughts is it would be around congestion management, but we're open to other topics as well. So,
great. Thank you, Paul. Okay, so that brings us on to our session presentations. I think the first presentation is for the Geneva Security Requirements draft. That's Daniel. Daniel, do you want that?
So, Geneva Security Requirements draft,
we had a we had a call for adoption.
And then we had a discussion. So we're still discussing draft. So I'm going to briefly list some of the discussions we had on that. So the first discussion was about transit nodes. So the current draft, maybe the one published, probably not the one but the latest version, we're considering transit nodes that are on path to and those transit nodes were to that be able to process within the office. And the discussion we had were, since my understanding from the discussion is that such transit nodes does not exist. And those transit nodes described in the architecture are part of not migrating of this new architecture fragment. So we stay with that. And we decided that, okay, the transmittal of the NV should be clarified into the occupancy document. And for the security considerations, we're now considering that these printed nodes are part of the NVP, which means there is no printed node. So this is a major change regarding security requirements from the CAP. So with respect to the acceptable group or to work with your number requirements. So the second point was the security model. The current draft divided the roles in the different actors running involved to the many all the way. So we have the cloud provider, on top of which we have the all the network engineers, on top of those we have the tenants. And these were pretty simple roles. Now that we don't have the tenants, so some discussions were, should we have the management of your organic different company cloud providers? I think somehow yes. Now we don't have any principles anymore. The division of the and the scope of the document. So this is a minor thing, but still, the initial scope of the document, version 2 was build up the requirements for GD security option. That, like I presented that for but add with a bunch of requirements to validate that one deployment is actually secure. So then we move the document towards that. But so I think that way it should go. But now some of the discussions are, do we actually need the GD security option? So it is not, well, this is small steps, but at the end we need to consider that we don't have any installation within the document. So I mean, the user scope has an impact on the document. So we just want to think of some and the other discussion we have.
Okay. Oh, you didn't hear? Oh, okay. Oh, okay. So the latest discussion, I think that's the latest point. Oh no, it's not the latest one. So the other things that raised some discussions was the security optimization versus requirements. So a typical example is that, well, we mentioned very, very clearly that we have to reuse whenever possible IPsec, DTLS, and so on. And it's true that DTLS provide encryption, authentication, and anti-replay mechanisms, but for the whole packet. So then, and this is also something that has been raised in the former security requirement document for NVO3. If the tenants are sending IPsec packets, it was mentioned as, you should not consider that as protected because the tenants are using IPsec. But on the other hand, you might be willing only to protect the header of the packet exchange between the tenants to enhance security. In which case, you don't encrypt the whole packet, but you just encrypt a fraction of this. So we had some discussions regarding, is it an optimization or should it be a requirement? Because at the end, okay, if you encrypt everything, you achieve this partial encryptions, but maybe the necessary resource is going to prevent the secure deployment of GNAP. So that's where I'm not so. We had some kind of discussion. Should we have one mechanisms that might prevent the secure deployment, or but that would be much simpler. Or should we also require that some of this optimization be part of the requirements? And there are a few cases where, so the document is not trying to make things very complex, but we were, when I was mentioning that initially the document was about the security requirements for Genève, we wanted to end up in two kind of things. So we wanted to have some eventually some mechanisms that apply to any environment, which doesn't mean that in some deployment, these mechanisms can be implemented in different ways and achieve the same security. But so sometimes there is a discussions whether it should be a requirement or an optimization. And flow management. So when you have a Genève tunnel between two NVE, one of the questions would, so do you multiplex all the tenants' communications between the two NVE, or do you want to be able to have different level of security within a tunnel, or do you want to have one tunnel with multiple tunnels with one level of security? These are still if we don't want the flow management being inside the Genève tunnel, do we want it to be handled by different Genève tunnels? So it's again, is it an optimization or is it a requirement? So these are the kind of discussion we had. And so that's all we have now. The documents should be, in my opinion, completely written. I mean, there were no discussion about the threats and the descriptions of the threats. So discussions are happening on the requirements. I would be happy to get your feedbacks before I provide a new version. Especially what I'd like to avoid is that some of the assumptions, especially the status of the transit node, because if you go back and forth, it has a major impact on the analysis of the security. The requirements versus optimization can be discussed once adopted, or I mean, everything can be discussed once we have adopted the document. But if I'm taking the time to rewrite the document, I'd like to minimize those back and forth.
Okay, thanks. Any comments? Langer.
Yes, this is. Are you able to hear me?
Yes, we are. Thanks.
Okay, good. I have comments. I mean, I think we have had extensive discussions with the security requirements authors, but I just wanted to point out that the transit nodes was as an important point where the security requirement document made certain assumptions that is not supported by Genève architecture. And there are several requirements that are associated with this. And then we have given detailed feedback to them saying that these are unsupported ones and we shouldn't have those requirements. That's number one. The second one is regarding the optimization versus requirement. I think Daniel discussed that one as well. So there are two things. One is multiple flows. We don't believe that multiple flows is more of a nice to have, and is an optimization, and it is not an absolute requirement to secure the communication between the two NVE pairs. That's one point. And the second one is on whether the tenant can encrypt the data. Or whether the tenant encrypts the data or not, if an operator deems necessary that the communication between the NVE pairs needs to be encrypted, and they will encrypt it. That is irrespective of what happens with the payload. And so we believe that that's also an optimization and not a requirement. So we have submitted detailed comments to the authors of the requirements draft, and that's not been addressed in the current version that's been released. And so with that, my opinion is it is still not ready for adoption. We still need to fix the architectural issues as well as some of these optimization requirements before it's ready for adoption. Thank you.
Okay, so you're planning on doing a new version, running a new version of draft, right?
Well, we're working on a new version, but it would be good to figure out that the assumption we had before were really bad. So it's more to see the direction where we have to go. And to me, optimization can be discussed all over. Multiplexing is going to be a should instead of a must, so that's not a big thing. The transit node issue is seems to me more drastic regarding because as Ilago mentioned, a lot of the requirements were coming from these transit nodes. So if there is actually no transit nodes as the way we understood those, the requirements are going to be completely different. So, and even the analysis. So that's why if we kind of fix on that, it's easier to have a more stable version.
Okay. I think given just one other comment, given that this was going through an adoption poll, it would be good to have more discussion on the list.
Yeah.
About it rather than necessarily in private, because we haven't formed a formal design team around this. So
okay.
If you and the Geneva authors could try to have more of the discussions on the list if possible, that would be good.
Okay.
Okay, thanks. So the next up is Ilango, remotely.
So yes.
Yeah, just give me a minute to.
Sure.
This thing full screen. Okay, thank you. Ilango, you can go ahead.
Yes, thank you. So I'll be presenting, the draft Geneva update and the changes that we made to the draft. So I'm presenting on behalf of the Geneva authors. I would like to acknowledge Sridhar, who had done extensive contribution during this Geneva draft update. So moving to the next slide. So we made the following changes, right? So one of them is the clarification on the role of transit devices, and this was an important point because it came up during the security requirements document review, and also we have seen some of the changes that discussion that has been happening on the OAM, and so because of that we felt that it is necessary to clarify the role of the transit devices. So we'll talk about that. And the other important point about the security consideration section. So we had made changes or added content to the security consideration section per the BCP 72 guidelines. And so I'll talk about that one as well. And we also made some updates to the option class assignment table. There were two organizations that requested for option class assignment, and then we have made that. And I won't be having any discussion on this point because it's more obvious from the updated draft itself as to the companies that has requested for additional option class assignment. So the one of them is actually Amazon, and the second organization is actually Cisco. So those two option codes are there, and we have been assigning it on a first come first serve basis. And eventually, we will, when this goes through the IESG review, we will transfer this over to the IANA. Okay. So let's move on to the next slide. So this is the clarification on the role of transit devices. So per Geneva architecture, the transit devices do not originate or terminate the genuine packet. Actually, that is the responsibility of the endpoints. And this is also, the endpoints are the ones which have the complete understanding of, what is this tunnel, and what is the UDP port number that we are using, and all of that association is actually with the endpoints, and it is not with the transit devices. So there were some queries, or I would even call it as some kind of a misinterpretation on the role of transit devices, and that was obvious during the discussion of the security requirements draft, and also some of the exchanges that we saw on the mailing list regarding the IOAM drafts. So hence we added clarifying statements so that it is very clear that what the transit devices can do and what it cannot do. So again, to clarify that point, right, as non-terminating devices, transit devices must not insert or delete options because that is the responsibility of the endpoints. There are two other sub points to that. Is transit devices may be able to interpret the options, but this feature is also optional, and that was also clear in the draft. We just made it, we made it very clear that the options ordering or options cannot be changed by the transit devices. So basically, we don't want the transit devices to be going and updating it, but it may be able to interpret the options. Again, this is not very new because any of the, if you look at UDP datagrams that are being exchanged between two endpoints, it is the same thing. Example, there could be transit devices that may be able to interpret it, but there may be cases where it may not be able to interpret it. But it is basically the understanding is the endpoints are the ones that establishes the connection and then maintains it. And also, we would like to state that there was a note, that transit devices must not attempt to interpret or process Geneva OAM packets, and there are no changes to the draft. I'm just reiterating it in here in this slide so that the working group members are aware of it. And that's about the transit devices. So there was also an exchange. I believe there was an exchange. I think Tom Herbert, and Greg Mirsky, actually they were having some exchange on the mailing list, and in that it was also clarified about the same point that you may not be able to update the options, and in which case if you have to use OAM packets, then it has to be based on endpoint to endpoint kind of an options. That's what you'll have to use. Okay.
Okay, have a couple of people in the queue for questions. Tom?
Okay, so you wanted to go through the questions before we move to the next security section,
Are
right?
they on this side? Yeah, let's do it. Well,
Tom Rahim, well. So the one before last bullet says options or the ordering must not be changed by transit devices. So actually the sentence says two different things. So first of all, I would suggest to split it into two sentences. One talks about the ordering and one talks about changing or not changing the option. Now regarding changing the option, again, you mentioned IOAM, so maybe I missed what you said, but how does this work with IOAM? If you can't change the option, what are transit devices supposed to do in terms of IOAM?
So if you are able to go and modify, as I said, right, the datagram has the meaning only at the endpoints, and even if you look at RFC 7605, that makes it very clear that the port numbers association is also established by the endpoints. So even though the transit devices may be able to interpret, that doesn't guarantee any security, that doesn't guarantee that the association will always be on this port number. So it's the same thing with Geneva as well. You don't want it to be able to go and change the content of the packet. That would cause issues, security issues, that would cause other issues with respect to what the communication that is going on between the endpoints. It's like this: like you are establishing a tunnel between the endpoint to the endpoint, and the endpoints are the ones that are establishing the tunnels and maintaining it, and you don't want the contents of that tunnel to be modified by the intermediate devices, and that was not an intent of Geneva architecture, and we just wanted to make it clear that that is the case.
So just to make sure I understand, we're saying that we're not going to support IOAM in transit devices?
No, if you are going to go and make a change, and if you're going to go and modify the packet, then what it means is that's an endpoint's responsibility, and then you need to be implementing an endpoint in order to make changes to the packet.
Thanks.
Thank you.
Hi, so Daniel Migo Erickson. So my understanding is that transit nodes cannot insert, delete, but the only thing they can do is read an option.
That's correct.
Correct. Okay, thank you.
Okay. Next slide.
Yep. Hold on one second. I'll just. Okay, next is the security considerations section. So we received feedback from the recently completed RFC. This is the NSH, the RFC 8300. During that review process, it was brought to the attention that security considerations section should be updated per the BCP 72 guidelines. And there was also a comment by Paul Quinn on the mailing list, NVO3 mailing list as well. So what we did is we added additional content so that we can highlight the potential security risk that may be applicable to Geneve deployments, and also the approaches to mitigate such risks. And that includes, data confidentiality, that is between the NVE pairs, and also, the data integrity to be protected to ensure that, the data, and also to ensure that the NVE pair is actually receiving data from an NVE that it is supposed to receive from. So the authentication of the NVE as well. So we have added additional information in there to that is clear in the draft to indicate what are those risk scenarios and how to mitigate those risks. And also we have added some additional information regarding how to handle the broadcast and multicast, and also the control plane communication. Some of this would be within the scope of this draft, and some of this may not be within the scope of the draft, because the control plane communication, for example, needs to be handled by, it's not, this is a data plane draft, but then we still point to that it needs to be handled, elsewhere. And then let's move on to the next slide. Before we take questions, we have one more slide on the security considerations section. Okay. Yeah. So this was, the comment raised by Tal on the mailing list. So not all the risks are outlined as applicable to all the deployments. That is very true, and that's exactly what we tried to communicate in the draft. So, for example, there could be risk that may be only applicable to, say, public cloud or multi-tenant kind of deployments, and there could be other risks that those risks may not be applicable to, say, for example, a private data center kind of deployment. And only the data center operator will be able to assess this risk as it is applicable to their deployment, and so they will be able to go and mitigate those risks accordingly. So what we tried to explain in the draft is to say that what are those risks, and under those scenarios what kind of mitigation that needs to be taken in order to enable those in order to address those risks. And also what we did is, we added sufficient information in the subsection so that it is very clear that, where these risks are applicable and where these requirements are applicable, right? And the comment was saying that, the comment was correct, right? It said that, the certain requirements may not be applicable to all operators, and it is possible to, so what we are saying is, like, it's possible to add qualifying statement to clarify that not all requirements are applicable to all the situation. That is very clear, right? We can have a qualifying statement so that there is no ambiguity here, so that an operator should actually do the threat assessment, and based on that, they need to enable the protection that is applicable to their specific deployment. And it's possible for us to make that clarifying statement so that there is no ambiguity that you need to apply a certain requirement to all situations. And yeah, these were the updates that we made to the draft.
Tal Mizrahi Marvel. So I completely agree with this slide. Can you go back to the previous slide? But how does slide 5 work with the fact that the confidentiality, integrity, and authentication are must requirements? I mean, if we need, on a per system basis, we need to do a threat analysis. Based on that threat analysis, we need to decide which requirements are applicable and which ones are not. Why are we requiring as a must to implement confidentiality, integrity, and authentication?
okay, it's a must in that particular scenario, right? It is not a must all the time. So if that condition, for example, let's say in a multi-tenancy data center, the requirement is to protect the data between the two NVE pairs, and that's the requirement. And in that case, the data center operator must enable it in order to protect the data, right? We can't we can't be not saying what the requirements are. So that is what is the, if you go and read through the BCP 72 guidelines, it's very clear that we need to identify the threat, and also we need to clearly specify what is a must, what is a should, or what is a must not. That needs to be very clearly explained. And if you go back to look at RFC 8300, that was recently went through this process. It was very clear that we have to provide such requirements, and that's exactly what we try to follow in updating the security considerations section here.
So the way I'm reading the current version of the draft, maybe I'm not reading it right, is that you must implement confidentiality, you must implement integrity, and you must implement authentication.
We can add qualifying statement. That's why I said, right, in the next page, it's possible to add qualifying statement to make sure that it is applicable only in such scenario, provided the operator has done the risk assessment, and based on that, they intend to enable it.
So I would really suggest I think we have to rephrase it, because right now it says something which is very difficult to follow. I think if we're saying you must implement confidentiality, and we're not defining an encryption algorithm, we're not defining a protocol, first of all, no one will implement it. Second of all, there's no way to interoperate, so it won't work. So I would suggest to be very careful about using the word must in capital letters. I would suggest to remove it, or to phrase it very carefully in a way that will be clear that we're not actually expecting people to implement it as a must, but only to use it in certain scenarios.
Tal, I think we still have to include the must statements in there, because we need to clearly specify that. But you can also refer back to the recently completed RFC process, and I also monitored some of the exchanges that went through during that draft review process. So we will have to clearly specify the risk, and we'll also clearly specify what those requirements are. But it is possible for us to add qualifying statements that in such a way that requirement is not applicable to all scenarios. It's only required in a specific scenario where that threat is deemed necessary by the operator.
Right,
Okay.
but I think you need to. I think, Tal, what you're saying basically is there's no point in having a must if you don't have a mechanism to back up that must.
Right.
Now, it's quite common in security considerations to give examples of protocols that can satisfy that requirement. So if there's specific protocols that you have in mind to provide these, then you can just list those as examples. It doesn't have to, rather than leaving it completely rather open-ended.
But the way we read the text right now, it says as an instruction to the implementer, you must implement these things. And as an implementer, I'm reading this and I'm saying, I can't comply to Genève because I can't implement confidentiality. I don't know what to implement. So we can't leave it like this.
Yeah, there are other ways to phrase it that are perhaps less prescriptive, but satisfy the kind of purpose of the security considerations section. So you can, this is just from my speaking as a co-author of other RFCs where we've had to do this. You just have to. You have to state what the threat is, and then say, and there are mechanisms available to, and list some mechanisms to mitigate against that threat.
So just as a suggestion, what we did, for example, in TikTok, we had security requirements. So what we did was we defined the security requirements for a security mechanism. That is, if you're implementing a security mechanism in a system that requires this mechanism based on a threat analysis, these are the requirements. Some of them are must, some of them are should, and so on. But that's if you're implementing the mechanism. So it's not a must to the implementer, it's a must to whoever is using or deploying a security mechanism. That's what I suggest to do here.
Yeah, point well taken. We will try to add sufficient or maybe rephrase it in such a way that it is very clear what we intend to do here.
Yeah, I think and one of the things that we intend to do with this document once we see a new version of it and start a working group last call is to ask for a security area review. So what I suggest you do is to write down what makes sense for an implementer of Genève here, because this is supposed to be specifying the Genève protocol. And hopefully we can get some advice back from the security area or some guidance as to whether or not what is written in there is adequate from a security perspective. So somehow we have to obviously come to a compromise here as to what makes sense for a protocol spec, while having sufficient text in there to also guide the fact that if you need to meet these requirements in certain deployments, obviously there must be a protocol, or the implementer must have implemented these other mechanisms.
So Matthew, shall we send the draft as is for the security review, or is it after we rephrase some of these sentences and then send it for security review?
Well, I'd be inclined to rephrase it in a way that makes sense for an implementer, first of all.
Okay.
Because it sounds like we don't yet have consensus on the current text in there. So let's get some consensus in this working group first, and then send it for wider review.
All right. Okay. Thank you.
Yeah, I think it's a good path to go through. I mean, because having strong security requirements that are not implementable, I don't think is going to be helpful for the review.
Yeah. I mean, that would be my concern, is having must statements in there that actually that they're not specific enough to say you must implement this protocol or that protocol.
Yeah, and one thing could be to mention, I mean, the existing things and what is missing somehow. And it doesn't have to secure in all sense or fulfill all the security requirements, but we have to understand both what it's doing, the limits, and basically position Genève regarding the security. And the security requirement draft should clarify that. This is my expectation.
Yeah.
Okay. This was Daniel.
Right. Okay, thank you.
So, any other comments on this draft? Okay, thanks very much. Oh, wait a minute, Daniel.
Just Daniel again. What is the timeline to submit this to the security area review or ISG?
Let's get some consensus. So if you could update with if you could maybe work with and Tal work with the authors to propose some text, maybe to the list for this section. Try and get consensus on the NVO3 list first of all. So in the next couple of weeks, it's only a couple of sentences, I think. So, and then we will revise the draft, and we'll go for I propose actually that we go for a security area review first, and then we work in group last call based on any feedback from that. So I'd definitely like to get a working group, get this sent to Martin before Bangkok.
Okay. Yeah.
So if we can try and aim for that.
Okay. Thank you.
Okay. Thanks. Okay. So next up is Tal with the Alternate marking.
Thanks. My name is Tal Mizrahi. I'm from Marvell. And this draft is a collaboration with Giuseppe Fioccola and Greg Mirsky. It's about using alternate marking in NVO3. Next, please. Okay, so in general, alternate marking, what we want to do, we want to measure the performance between two measurement points, MP1 and MP2. And what we want to measure is the packet loss, the delay jitter. Now, in the context of NVO3, the measurement points are NVEs. And what we'd typically like to do is to measure the performance on a per VNI basis. Again, the packet loss, the delay jitter. So the way alternate marking works in RFC 8321 is that you use a marking bit in the header of the data packets. And this marking bit, its value changes periodically, like a wave function. And it kind of splits the data traffic into consecutive blocks of data. And this allows the measurement points to count the traffic consistently, which allows you to compute the packet loss. That's in a nutshell without going into details. So this is the marking bit. It's also called the color bit. Now, the double marking method uses 2 bits, and the idea is that 1 bit is used as a color bit. It's used for loss measurement. And the second bit is used for delay measurement. And the idea in the delay bit is that most of the time it's 0. And then once per period, its value is reversed. And that specific packet in which the value is reversed is used as a reference for delay measurement. Okay, it's time-stamped by both measurement points, and that one is used for delay measurement. So this is double marking. It requires 2 bits. Multiplexed marking basically multiplexes the 2 bits onto a single bit. So that single bit is actually the result of the exclusive OR between the L bit and the D bit. So what we get is we get the same functionality as the double marking, the same measurement accuracy, the same measurement resolution, using just a single bit in the header. So what we're proposing in the current draft is to allocate 2 bits in the Genève header for the purpose of alternate marking. So once you have these 2 bits, you can either do single bit marking or double marking or multiplex marking. Each of these is possible. Now, one of the comments that was made on the mailing list is that in some cases, maybe 2 bits is too much. And so it's up for discussion, but if we end up deciding that we can only allocate 1 bit, that means we'll still be able to support single marking or multiplex marking. Okay, so again, it's up for discussion. So there was a discussion on the mailing list, a few comments, and based on these comments, the draft was updated. Draft 02 already reflects these discussions. And at this point, we believe the draft is ready for working group adoption. So we'd like to ask the chairs to consider working group adoption call.
So Daniel Bigot Erickson. I have one clarifying question. Is the marking and the reading of the marking being performed at the NVE or any node in the network?
At the NVEs, okay? The idea is that the NVEs are assigning that marking bit, and the NVEs, the terminating NVEs are using that marking bit.
Okay, thank you.
Okay, thank you.
There's a question from Elango.
Yes, I think it's follow-up to Daniel's question. So to be clear, right? So basically what you're saying is the NVE is the one that is marking this bit, and NVE is the one that's consuming this bit as well.
Right, yes.
Okay, thank you.
Okay, so can I get a show of hands? Could you put your hand up if you've read this latest version of the draft, please? Okay, it's about 3. Okay. Okay, thanks. Oh, there I go again.
Another question. So if that is the case, then why won't they use the options in order to do this? Because that was the intent of having extensibility in Geneve rather than using the base header, because you can have the option to indicate this information, and you're not limited by number of bits. You have a lot more space in order to do provide metadata between the NVE.
Right, you can use the options, but the idea is that since this approach only requires a single bit or 2 bits, it's a very small number of bits, it's a bit of a waste to use an option for this. If we can spare a bit or 2 for this in the Geneve header, we can just be more efficient and still get that functionality.
I mean, I believe that this is exactly the reason why we have extensibility, and also not all the deployments will need this. So it would be better to have an option, and then and then have, you are not limited by 1 or 2 bits. If you want 1 or 2 bit, that's fine. But if you want to use more, that allows use the extensibility feature of Geneve in order to do this. So that's my opinion.
Hi, this is Greg. If I may provide a couple comments and answers. Strictly speaking, there is no consumption of the marking field. And I probably have different opinion from Taos that effectively the test point that acts on the value of the marking field can be anywhere in the tunnel. It's not necessarily in the edge NVE. Okay, and the benefit of using fixed position of the marking field is that simplification of the operation of the test point, because then it makes its well-known position in the packet, rather than you need to parse the variable length portion of the header to identify where the field is.
So is that a question to Tal, or is it?
No, it's not a question to Tal. It's basically my answer to your suggestion to use a variable length extensible part of the header for the marking field, because that will make it hardware support of it less efficient. Again, I want to point that this method is, even though it's this classified as a hybrid method, similar to other hybrid methods, it does not transport data in a packet. The data being calculated locally at the test point and then can be exported out of band. So, which makes it even more efficient, because you don't need to transport in each and every timestamp the marked packet flies by.
I mean, I still believe that you can use the options for this purpose, and because most of the Geneve endpoints that are implementing will also be able to implement options. This is not just the one, and the efficiency is not an issue. So I don't believe that efficiency is an issue, whether you're interpreting an option or whether you're interpreting bits in an option.
Okay. Yes, I agree with you. Everything can be done differently. There is not one way to slice the bread, but in terms of performance monitoring, being able to identify the packet as close as possible when it's being received, it's almost critical, because if, for example, the timestamp is not taken during the reception, the physical reception of the packet, then you are measuring something else. Basically, you are measuring internal queuing delays and internal processing rather than propagation delay. Okay, and that becomes a variable, so the quality, accuracy of their measurements suffers. We can discuss it at length, but I want to assure you that it is important.
Yeah, so Greg, I think it's Matthew here. I think I had a similar comment. If you're adding options in a performance monitoring, so you're making the packets bigger, your PM packets bigger. You don't want the fact that you've added these additional option fields or headers to impact your OEM measurements, which are supposed to represent the user traffic behavior.
Well, again, the alternate marking method works on the user traffic, and the idea is of using pre-allocated field in a fixed size header, or at least fixed sized portion of the header, makes it almost as passive measurement because there is no increase in the size. As Tao pointed out, the size of the flag is so small, so adding option will be significant overhead to the actual size of their marking field.
Right. I think we're saying the same thing. Okay. Any further comments or questions? Okay. Thanks. So the final session is Greg with overlay OEM identifiers. So I believe this was already presented in the routing area working group.
Absolutely, yes. Actually, the document, I talked only with the RTG group chairs about the idea of starting this document, and they suggested that because it combines analysis or reviews work being done in several groups, even areas, starting in an RTG-VG may be good first step. There are some open questions about their path for this document and its life cycle, span, but it will probably be better to get to that at the end of the discussion and presentation. Can we go to the next slide, please? The question I had is when looking at and having discussions in groups that work on overlay encapsulations is that how we achieve unambiguous identification of OEM. And OEM has three different methods. So it's an active OEM, hybrid OEM, and passive OEM. Passive OEM, it's always out of band, and it's monitoring or sending out some data, and it's not in scope of this analysis. In the active OEM, it's characterized as a method that uses specifically constructed test packets. And what we achieve with these methods is the fault management and performance monitoring. It's a F&P of FCOPS, network management paradigm. These methods could be single-ended or dual-ended. So the single-ended example would be echo request reply, like ping. Dual-ended, it's example BFD in asynchronous mode, when two ends independently send periodic packets. It could be a two ways or one way. The two ways, again, it's an echo request reply. In one way, it's BFD in demand mode when only one endpoint transmits packets. Then we have the hybrid OEM. In IPPM working group, where we discuss different performance monitoring methods, performance measurement, the hybrid OEM was defined as a method that combines characteristics of active OEM and passive OEM. And the weight of each method that contributes to the hybrid OEM could be different. So examples of hybrid OEM could be that what we discussed just earlier is alternate marking method that triggers measurement. In situ OEM is another example that triggers measurement and at the same time collects and transport the measurement results or network state information, what we use sometimes refer as a telemetry information in the data packet. Another example is a hybrid two-step. It's a method that collects and transports their telemetry information. I think that overlay network protocols can be separated in two categories. Encapsulations that support optional metadata, so thus it's variable size headers, and that includes Geneve, SFC, NSH, GUI, and encapsulations that use fixed size headers, so they don't support optional metadata, and these examples are Beer and VX1 GPE. So, looking at Geneve document, which suggests to use OBIT to identify OEM packet, it says that this packet contains control message instead of data payload. But at the same time, when we look at example of in situ OEM, there is a proposal that the packet may contain both OEM data and payload. So thus, there seems to be a contradiction. In GUI, the OEM packet is not defined, there is no mention, but the mechanism that it suggests is to use CBIT, which changes their interpretation of command protocol field, and if the CBIT's set, then it means that there is a control information, and in this namespace, OEM can be defined as a command type. My note to that method would be is that if there is an intention to separate slow path processing from the fast path processing, so if CBIT set, then it goes to the slow path processing, that some OEM methods are hardware implemented, so basically like BFD or performance measurement, precise, accurate performance measurement methods. And making this differentiation based on fast path, slow path, whether to send to control plane or do the faster processing, it seems to be not really well aligned with how OEM or some OEM methods work. Okay, next slide, please. SFC and NSH, that basically there already was Ilana referred to discussion of 8300. It's a very limited, so on talking about OEM, and it says that OBIT in a fixed header indicates that OEM packet. OEM framework, which is a working group document, talks about again, that there is an indication of OEM packet, but it doesn't say what OEM packet actually is. Recently adopted IOM in NSH document has a little bit more about IOM specific relationship with O bit. And the reason for that is that this document, IOM and NSH, currently suggests two options of encapsulating IOM information in NSH encapsulated packet. One would be using TOV, and another would be using a payload immediately following the NSH header, whether it's fixed or using metadata type 2. Next slide, please. Adrian, with the co-authors, they have very good observation, and that reflected in RFC. Oh, okay, sorry, I'm jumping. Fixed size headers. So in the beer is very, very simple. Beer allocated next protocol identifier for OEM, and it's registered in IANA. So OEM packet that follows beer header identified through the protocol field. VXLAN GPE introduce O-bit, and it says nothing more than says that indicate that the packet is OEM packet. Please note that all the protocols, VXLAN GPE, GUI, Geneve, and SH, they have next protocol field. So let's go to the next slide. So the question is that many documents talk about OEM packet. What is OEM packet? Is it a packet that where the OEM commands and information included as metadata in a header, or OEM commands and information immediately follow the header? And because encapsulation that has OEM flag and next protocol field, there is ambiguity. If you have O-bit set and the next protocol pointing to some protocol value, what is the packet? And where the OEM information located? So I started talking about this RFC 8393 earlier, and that was the observation made by Adrian and co-authors that next protocol none was not defined. And next protocol none means exactly that there is no payload following the header, NSH header in that case. And then they made the next logical observation that if the O-bit set and the next protocol value is none, then OEM data located in TOV as a metadata can be used as active OEM mechanism, which is absolutely correct. But the problem would be is that length of metadata is limited in NSH to 512 octets, and I believe that Geneve limits it even more, only 128 octets. And that limits their applicability for methods that needs to generate arbitrary packet length, for example, MTU discovery, or just to measure performance packet loss and delay without traffic. So basically doing as a synthetic traffic generator using test packets. So again, yes, it's possible, but it will have limited capability. So again, the question still stands: how to identify OEM command information that immediately follows the header? Next slide, please. I'm proposing the following recommendation. if the protocol encapsulation uses O bit, that their interpretation of the O bit is only for their content of the header. If somebody wants to use to transport or include OEM command or information in metadata, then you use OEM flag. The presence of OEM commands and information following the header, which is the case for active OEM, identified through the next protocol field. Okay, next slide. There is some discussion in the document on active OEM over MPLS that doesn't use IP UDP encapsulation because with IP UDP encapsulation, it provides you with the source identifier. If IP underlay, that natively provides a source ID. But if it's non-IP encapsulation with the MPLS data plane, so the source ID has to be included as a separate information from their OEM command and data. But it's not very specific to NVO3. Okay, can we go next? Right, so that's probably not necessarily discussed now. And the next slide. So these are next steps. I will continue working with the document. I will update document on GUI to reflect a discussion with Tom, and I appreciate his input because he pointed to the right direction. I appreciate comments, questions, suggestions, and the last question is that what we do with this document. I intended it for starting discussion. Probably it can have, it might be used to record the discussion and reflect it. Publication, it might not need it. So if it leaves and we can agree on how to identify OEM consistently and unambiguously, then I will consider the document serve the purpose.
Okay, thanks, Greg. Any comments or questions on the draft? No. Okay. So I guess one of the questions really is where to discuss the draft, if it should be on the routing, in the NVO3 list or just within, because that's only really specific to the NVO3 aspects of it.
Right.
Or within the context of the routing area working group.
As a final comment, Jeff asked that, well, because he was aware that I'll have presentations NVO3 and then SFC working groups. So he asked to summarize their discussion. I think that, again, if somebody wants to have it in one group, but it might be that the discussion should include all these groups. And actually, I think that because there is consideration for GUI, maybe we need to involve this group that works on GUI as well, to make them aware of our discussion and our arguments.
Martin Vigoa speaking. A question to you two. According to you, what is the set of competencies needed for that document? If it's an NVO3 mainly or only, then it should
no,
be.
I definitely want to have impact on SFC. I want them to think about it and to discuss it.
Okay, thanks.
So given that the document kind of surveys the mechanisms that are in place at the moment in the various OEM and the various overlay encapsulations, and that some of those encapsulations are quite, well advanced, and there's implementations of them. What do you see the value of the document in terms of, do you see that, I don't know if the document's going to change encapsulations, or are you hoping to change encapsulations that exist today? Use a common mechanism.
No, again, I try to make my recommendation as least intrusive as possible. So, for example, we have probably the most advanced would be SFC and SH. For an SFC and SH, again, we don't have we haven't made much progress on OEM work. And the framework, OEM framework, is still being worked on. So my proposal will not require, even though it's possible, but again, we may redefine the interpretation of all bit in NSH header, and we just then define the value for next protocol to identify active OEM. So I don't think that will be very big change, and I would see it as being backward compatible. But definitely it's worth discussion, because people might have some ideas, and
Okay, so if I could encourage folks in this working group to read the draft and probably provide feedback on the routing area, into the routing area working group from an NVO3 perspective. I think so, that would be the way to do it. Okay, thank you.
Thank you.
Thanks. Okay, thanks. That's the last slot we had. Blue sheets. If you have a blue sheet, could you bring them to the front, please? And I think that's the end of the meeting. Thank you.